Okay, let us recap on our previous online class last week. So let me share to you. Okay, last class we have learned on how to design and analyze a stable slope. So what I'm going to show this morning, just to recap what we have learned or what we have found from the previous class. Because what I want to say this morning, after I have gone through few checking on the LA week 9 assessment activity, what I have found is that some mistake have been done by you all. So let's say we have a slope here with a certain height and with a certain angle, and this is the circular arc. And the first of all, what we want to say on that part is you have to identify which method are you going to analyze, whether you have the mesh procedure or you have the method of slices. So for this one, we might use the method of slices for our slope stability analysis. So the meaning of the method of slices is that the soil mass above the slip circle will be divided into equal vertical slice. So for this case, let's say we consider the first slice here, assuming as a W1. Here is a W1, and then we can divide another into two slices as a W2 and W3. Okay, actually this is only freehands lah. What you need to do is divide into equal slice. So this W1, actually we can have another one. Similarly goes to the W3. What I want to stress on about the how are you going to take the area of the slices before we can have the volume of the slice, which is W1. So the most important parts when you draw this slice, and you need to tabulate the table with the appropriate parameter. So this is the common tables that I think every one of you have done on this part. So we have the slice number, we have the B is the width of slice, we have H1, we have H2, we have the area, and we have the W, and then next one is we have alpha, we have T, and we have also N. T and N are interslice components that deriving from the W. The T is equal to the W sine alpha, and W is a N is a W cos alpha. So T is the disturbing force, N is the restoring force. So slice number 1, let's say we have slice number 1, okay, and B, if you measure here from here, let's say we have the 2 meter. When you draw on the graph paper, so 2 meter, we can take a scale like 1 centimeter is equal to 1 meter. And then how do we locate the positions of the centroid for this W1? Due to the assumptions that we considered this lies in the shape of trapezoidal, so you can have that the centroid of these slice for W1, assuming that we have a square. So the W will be acting at the half of the B. So if you have a B is equal to 2 meter, so divided by 2, 1 meter from left, 1 meter from right, this is the positions of the W1. What's the importance of the W1? Because the W1 will affect you the alpha, the interslice angle from the O to the base circle here. Okay, let's we take O, the center of the slip circle, from here to here. Okay, so the W is located at the half from here. So where is the alpha? Alpha, when you consider from O to the base of the W1. So this is the positions of the alpha. If the alpha located on the left sides of O, so alpha must be negative. If the alpha is located to the right side of the O, so the alpha is a positive, will be affecting in the calculations total T and total N. What are the important things? The next one is on how to calculate the area. Since I said just now, we considered here is a trapezoidal, so you have to consistently using the formula of trapezoidal from slice 1 until to the last number 4. So don't miss out. For example, slice number 1 is a triangle, and then number 2, number 3, number 4, you consider it as a trapezoidal and triangle. What I want to say is that you make consistently calculations in the formula of A, that will be easier for you to remember, so that you don't confuse about it. Okay, for the previous attachment on the answer week 9 LA, the answer scheme showed to you the formula using the half of the H and then the area calculating using the triangle formula. It's okay. The thing is that you need to do next is check and compare what's the best design FOS need to be considered, whether you're using the trapezoidal formula or using the triangle. But this time, because I'm going to check on your answer script for next assessment, so let's us do one standard formula to have everyone get the right one. For reminding again, the A must be calculated using the trapezoidal formula is a half times B times H1 plus H2. And then similarly for W2, W3 and W4. The W2, W3 and W4, even though here is a slip, here is a circular slip, for the calculation we might take it as a straight line at the base of the slip circle. Again, you know that this P is equal to 2, you divided by 2, you can have, this is the centroid of the W2, and then get the alpha from O to the baselines of slip number or W2, that is the positions of the alpha. And then some mistake that I have found is that you know how to calculate A, you know how to calculate W, and then alpha can be found from the measuring. The error was considered or the error was done during the calculations of the theta. Remember, the circular arc here is equal to the L R theta. So the strength of the slip mass or the strength of the soil mass above the slip circle is resistant by the strength of the soil Cu and also the R theta. So the R theta is actually equal to the L. How to calculate theta? Theta just now I said in the radian. So R theta when you convert to the radian is a, let's say you got the theta here, for example, is a 70 degree. So 70 degree over 180 times with pi, so automatically your theta here dah convert into radian. So that's how you calculate the L. And the next one, when you use the formula to calculate FOS, please check, are you using the right formula for total stress analysis or you are calculating for effective stress analysis? Check the formula again. Don't simplify use the formula, because some calculations that I found from you is that you are using the formula such as C power of 2 R theta plus summation N tangent phi over summation T. So which part is wrong? The error, the mistake was done at the equation here is a to power 2. Actually, this is not the right formula to calculate FOS. The formula for calculating FOS in the ESA is a C effective R theta plus tangent phi summation N over summation T. Somehow, when you have the formula or whatever formula you have learned through the online class or from the textbook, please refer correctly you are using the right one, because I'm afraid if you simply taken the formula, that will be given to you the wrong calculations. Remember, when you are designing and then you say that, oh, FOS is okay because you have FOS more than 2, more than 1, without checking the appropriate input from calculations you have used. I'm afraid that the design will be the right one when you construct the slope on site. So please check again before you finalize your design or before you submit your calculations. And this is very important in the step of chapter 3 in slope stability. Okay, I think that I have touched on the importance part, because this is what I want to say regarding to the examples calculation that we have shared last week. So I have checked and I have assumed some mistakes has been found from there. Then I think that you need to check again which one the right to be used in your calculations, because we don't want to lose mark lah in your next exercise. So I think that some of class have been given the assessment on e-test, so you can check your marks on from there, and then you can guess what will be the final assessment mark that you're going to have, so that you can pass this subject. It's not pass only. I hope that you can have a good grade for this course. Okay, let us continue with our next class on the chapter 3, the last subtopic chapter 3, which is slope maintenance and slope protections. This is continuous from the previous one. So after we have designed our slope, how to maintain the slope in stable conditions. So back to the, I have shared with you or not? Let me share from here. Okay, this quite simple because the last subtopic here will be no longer consuming time, but I hope that okay, I have attached here, so you can check from the notes given. So we'll be on the next one, on the last subtopic. And for your informations, this week will be my last online class with you all. Okay. Okay, class, do you have any questions regarding to the previous what I have shown you just now on the calculation, slope stability, effective stress analysis, total stress analysis, using the apple-shaped strength parameters? Read question carefully, and then find the important parameters before you start doing calculations. Okay, this will be our next subtopic, slope protections and maintenance. Okay, the keywords or the wording from here indicate to you how to protect, how to maintain our slope after we design it. Whether you design for long term or short term analysis. Okay, the learning outcomes from this online topic is you are able to describe the slope protections and maintenance. You will be identified few types of maintenance work and protections. And then as you see here, we have only subtopic slope protections and maintenance. And we go next to the next one. Okay, introductions to slope protections and maintenance. It is very important for you to know about this one, since we can see the major constructions has been done on the slope. For example, on the hilly slope, because some purpose on the business, commercial, and then for tourism, and how to mitigate from the slope from fail for the immediate constructions after long time of the constructions. So when you read from here, with the increase of populations and exploitations of land resources, slope problem has become one of 3 global geological disaster, ranking with earthquake, volcano, owing to slope instability, collapse, landslide, debris flow brought massive loss for people's life and property. Slope stability problem becomes more and more prominent. It involves excavation slope of high-rise building, road slope, railway slope, hydropower engineering slope, and mining engineering slope. So during the engineering construction, slope protections and reinforcement should be strengthened to ensure Engineering quality and rate of progress. First, according to locate climate environment, engineering geology and construction materials, engineering types, comprehensive measures should be adjusted to ensure stability of highway subgrade. If necessary, slope protective engineering measures should not be cancelled or decreased. The slope protection and reinforcement also need to be taken into considerations when you're dealing with the under poor climate and hydrological condition. As for rock slope or looser slope with silt fine or easy to be weathered, it should be protected in time after earth and road and rock constructions. As for score protection, generally at sections of small water flow rate or weak flow disruptive effect paving stone, pannier and precast slab to protect subgrade side slope along river. So these are the conditions when you are dealing with one project. For example, you are given a task, and then as a geotechnical engineer, you need to construct a highway slope, for example. Before you start doing the constructions, you need to find some important parameter, the history about the slope on or about the site itself. You need to get the soil parameter. You need to find out, is it the slope has been subject to previous history failure such as, and then does it have a weathered rock, and is it has drainage water flow below the surface. These are the things that you need to find out. And then when you are dealing such as in Malaysia, we have humid climate. So how to deal during the constructions, and then how to mitigate in the long or in the future. And then when you understand the behavior of the site soil itself, that will be easier when dealing in dealing with during that time. And the important parts beside the informations given from the site and from the soil itself, you need to know the purpose of your constructions, because different purpose will give you different objective of the projects. If you are purposely construct the slope for highway, or for house constructions, or for housing area, so that's there will be different methods approach in dealing during the construction and after the process. So these are the guidelines when you have to work with with the site and with the problem. Slope protection and maintenance become the major ones when you have faced few disasters, such as in the landslide, and then we have some sort of erosions, we have some sort of the flow debris. So these are the things that you might not seen during the time, but when you trace the record in the previous report, you will see that, oh, this site has subjected to previous landslides, and then how does we need to deal with and mitigate from this to happen in the future. Okay, when you go to the next one of these slides, these are the types of the what we call it slope protections and maintenance work can be done, such as unloading or changing the geometry of the slope, buttressing, structural stabilizations, improving drainage, slope reinforcement, soil improvement, and vegetations. So some of these from seven of these type slope protection and maintenance, we have discovered, we have seen, we have learned from the previous topics, such as foundations, and then we have during the site investigation, and then the next topic will be also covered for the structure stabilization. So these are the things that purposely can be used for slope protections and maintenance. So the left side of this figure give you the idea how one existing slope can be maintained, can be protected from fail by using the, such as we can place with the retaining wall, and then using the appropriate drainage. That's why when you travel in the expressway, you will see on the left side, for example, you have the retained slope, highway slope, having such as shotcrete, and we have drainage because we want we allow for water to drain through, so that the soil do not need to retain water inside it, because you know that water will give additional loading and causing to the disturbing. And the next thing that we can provide for slope repair or maintenance using the rock bolts, sheet piling, and then you can use biotechnique slope stabilizations. And the next one, you can use friction piles. And then we have the geogrid or geomembrane. Same goes to the right side of this figure. So the idea of this figure indicate to you if you are using the structural stabilizations to maintain slope. Okay, for example, the methods here dealing with the soil nailing and then rock anchoring. When I said these two things, it's not simply that you using before you know what's the material of the soil. Some slope maybe have the weathered rock, and then some slope may also have the loose sand or loose soil. So the approach in methodology to retain or to repair the slope must be relying on the soil type of the slope. So it's not simply using the soil nailing, such for example, or using the rock anchoring or rock bolting. So when you understand the behavior of the soil itself, so you can choose, you can pick up the right methods to maintain or to repair the slope problems. And the next one, we go to the first method using the unloading and changing the geometry. So this is the very common method. You can see the stepped slope. If you have a steep slope, so you unload or you change the geometry of the slope to maintain the stability. So you can see that by doing the excavations, you reduce the slope height at the top of the slope, and then you can flatten the slope angle. And the next one, you excavate a bench in upper part of the slope. So the recommendations for you to what we call it here, to flatten the slope using the approach angle, such as this is according to classes, class 1, class 2, and class 3. The recommended angle, if you want to flat the slope design or the slope geometry. I think that this is the very simple one, unloading and changing the geometry. How do we know that the slope need to be changed the geometry if you doing the first step using the calculations? Because that from the first calculations, you have the informations on the slope geometry, slope height, and the slope angle. If you calculate and then you find out the FOS is lesser than 1, so you can readjust the slope angle or the slope height so that you meet the FOS equal to 1. That's the idea when you are dealing with the first step to maintain or to protect slope from failure. And then the second one, using the buttressing. Buttressing is one sort of the structural strengthen of the slope. The same objective to retain slope from failure. So this is the method or the process you dealing with the buttressing, such as you have the shear key, and then the buttress can be located along the slope face here, or it can be half of the slope face. So we place also the shear key, and you can see that the buttressing is recommended to be used when you have the weak soil on rock. And also that on the right figure, so the process, the typical buttress face slope suggested to be designed when dealing with this kind of the type of the slope protections and maintenance. You can over excavate the cut slope or replace the overcut portions with high quality fill, and then you are placing the shear key at the buttress structure here or at the slope face. And the next one, you are using the structural stabilization. The structural stabilization is a common method that we have seen on our slope maintain. So for example, here we can use the retaining wall. Retaining wall can be such as gabion wall and then the gravity wall, or you can have the drill cast in place vertical piles or drill cast in place vertical piles tie back earth and rock anchoring nailing reinforce earth. So these are the things that you might see in common lah. I think that the gabion wall, and then on the right side figure here showing to you if you have the anchoring soil nailing system to protect slope from failure. So all these type of slope protections and maintenance are depending on your budget of the project. I mean that if the projects are having a huge amount of money to support the slope protections and maintenance, having the critical problems, so you can choose the right methods. If you have a small budget and the problem is not so much critical, maybe we can opt to the simplest one, such as unloading or changing the geometry. If you dealing with these kinds of the structural stabilizations, this is my seen for major project. For example, if you are dealing with the deep constructions, high-rise building, you need to excavate a few meter below ground surface, and then there's a slope face that need to be retained. So these are the things that you can use for maintain slope or to retain slope from failure using the structural stabilizations. As I said again lah, this is depending to the project purpose and the budget. And the next one, if you dealing with the slope, don't forget to provide drainage. Because of what? We first of all, this is the such as if project in Malaysia. So you know that we have a humid climate, we have a rainy seasons, we have the dry seasons. So just imagine if you maintain the slope and then you forget to provide the drainage, what might happen later on? You will see that the slope will be having fully off water and fully water saturations that can cause to the slope failure. Later on, you will see that flowing debris and then landslides might occur due to the improper drainage design. The drainage is very, very important. Even though you only have one small drain or trench, and then just imagine the drainage is flogged by a debris. So you stop water from flowing out. So the consequences of the problem is that there will be flooded. The area will be flooded by the water. Same goes to the slope. If you not design a proper drainage, so the problem later on you will see some water flowing out, and then there's a fully saturated of soil, and slowly the water will fill. This is the recommendations how you can place the drain inside your slope in horizontal drain, for example, or using the dewatering well. The use of wells and horizontal drains to remove subsurface water. Okay, for this drainage, we have surface water flow out and we have also subsurface water flow out. So the surface is conditions to let surface water flows away from the slope. Meanwhile, for subsurface to remove water that already exists in the ground. And the white figure here shows to you how we can place the horizontal drains using the horizontal gravity drains. You inserted into the slope, and then you know the locations of the water level, groundwater level, and you have the initial groundwater level on top of it. And if you place one drainage, how that this thing will tackle, and then you also provide two drain at the end of this slope, at the two slope. So the purpose of this horizontal drainage surface or subsurface is to allow water flowing up. because we don't want to retain any water inside the slope. And the next one is using the geogrid or geomembranes. The geogrid and geomembranes, this is the something you may seen on the slope face. Let's say after slope has been filled and no repairing works has been taken place. So in temporary we can place the geomembrane to retain slope from fail as a temporary work in repairing, or you can use the geogrid and the geomembrane for long-term repairing work, so using the appropriate method of constructions. So this is some example of geotextile. So the geotextile also can be used for soil stabilization. So it can come together with the geotextiles, soil stabilization, and etc. And this is the kind of the slope reinforcements. So you can see that the geotextile being used on the slope face is some sort that has been designed with appropriate length, diameter, and then the space. So and the slope is reinforced using these methods, so that you don't need to use a pi such as, and then we have, other than geotextile, we can also use the geogrid. So the geogrid, so this is the cross sections how the geogrid are being placed on the slope. So the vegetation is there, and then you place on the geogrid at sites here. The same objective is as what we have in the geotextiles. The only difference between these two things is the designs of the reinforcement of itself, such as geogrid may be different in the size of uh, the grid or the membranes of the geogrid, such as you can see that the design of maybe in the different space and different length. Same goes to the geotextile. You can see the sizes for each space will not be similar. So there's a purpose why we use the geogrid and geotextile, but bear in mind also the cost involved. The cost involved in the project might be high due to this product. And the next one is using the soil improvement. The soil improvement is a common method such as chemical stabilization using cement or lime, and then using the thermal stabilizations, biostabilizations, natural and byproduct waste stabilization, or electro-osmosis. So you can see that this is how the figure shows to you using the chemical stabilization such as cement or lime to strengthen the soil of the slope from moving. So that this is also a method that we prevent any water infiltrate into the slope. So what's the purpose you are using the soil improvement? Because we want to increase the strength of the soil by adding these components or this element. And the next one and the last part of here is the vegetations. Vegetation is the common thing that you might see after the slope repairing has been done and mostly finished. So you can see that some sort of the vegetations purposely to protect from erosions, and then draws water out of the ground, provides some reinforcement of the soil, and it is also used as a aesthetic value. So you can see that this is the process involved, such as you place on the geogrid and geotextile, and then lastly we place the vegetation on the slope face. So you will see that the slope some sort of the original slope, because we have placed together with the vegetations. The vegetations and if you look at, actually it is provide to you as a root strength. The root strength is adding additionals or another things that being considered in the field area, how to strengthen the slope. The vegetations also is one sort of the process that we can strengthen using the root itself. And you know that when we bind the structure or the soil structure with the root, so that it can give the soil particles in high strength. This is the process or the types involved in slope protections and maintenance. Last but not least, I would like to play this short video.
Betul masih tak? Dia masih tak play pun? Tak play pun?
Okay, wait a second. Let me. Um, okay. Okay. Can you see and hear from here?
Boleh tadi boleh je.
No voice.
No.
Boleh nampak screen tapi suara dia tak ada.
Oh, suara tak ada.
Uh.
Okay, never mind. Let's see this. Okay, thanks for watching. I'm sorry because that so maybe the audio is not in good conditions. So do you have any questions before we end our online class today? You can ask on the previous topic 3. So there's a time for you to do some exercise and to do exercise. And for your information, just to remind, so next Friday will be our assignment 1. Okay, again we will cover topic 1 and 3. So you still have time. I hope that you don't have any problems to get a graph paper, etc. That's are the things is very important tools during the assignment. Any questions?
No.
Okay, so all the best. Good luck for next week. Thank you. Assalamualaikum.
Salam.
Thank you, madam.
Thank you, madam.
Thank you, doctor.
Thank you, madam.
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 Apa dia tanya masuk?